In this final segment, we'll look at finding the period of an annuity. This isn't very common because it's typical that you already know how many periods are left in some type of an annuity based on payments or based on the payment combination of the interest rate and the current value of the annuity. But in this example, we want to know how long it will take for your savings account to accumulate $1 million, assuming that it pays 4% interest per year. And you deposit $10,000 per year at the end of each year. So this is like a typical problem that you would have for a retirement portfolio. You know you need so much at a certain time period, and you're going to deposit in regular intervals, and you want to know how much you can accumulate and how long it's going to take you to get there. So we can see that this is a ordinary annuity because the payments occur at the end of every time period. They don't start today, they actually start one period from today. And we don't know how many periods it's going to take for us to accumulate $1 million. So let's solve this using our financial calculator. If you have BGN here on the face of the calculator, you need to make sure that you change it to the end or an ordinary annuity. We will clear time value of money. We'll make sure that our payments per year are set at 1. We haven't changed that, so there's no reason to suspect that. Now we're solving for the number of periods. We are collecting interest at 4%. We're not starting with anything, so we actually have a 0 present value. And we're making these $10,000 deposits at the end of every year. So I'm going to make that a negative payment, or a negative, meaning an outflow. And I want to accumulate $1 million in n number of periods, which I need to solve for. So we have all of our functions except for the number of periods, so we compute the number of periods. And this tells us that it'll take us just a little bit longer than 41 years in order to accumulate $1 million, or 41 equal payments plus a little bit in order to accumulate $1 million. So let's say you plan to start a savings fund to pay for your child's college education. You estimate that you'll need $150,000 15 years from now. Your financial advisor says that he can earn you money at 7.5%. You plan on making annual contributions. How large those annual contributions need to be. So now, rather than solving for the number of payments, now we're going to solve for the size of the payment, knowing that we have 15 years in order to reach this goal. Once again, it's still an ordinary annuity because the payments occur here at the end of every period. This time we're going to be solving for the size of the payment. We know we have 15 years, so we're going to clear time value of money. Clear that as well. We have 15 equal payments occurring at the end of every time period. We're going to accumulate at an arithmetic average of 7.5%. We're not going to start with anything, so when we clear time value of money, that actually became a 0. If you want to, you could put a 0 in for the present value. But we want to accumulate $150,000 15 years from now, so I'm going to make the future value $150,000 and compute or solve for the payment. Now we can see that it's negative. That negative represents an outflow, so we need to deposit $5,743.09 in order to accumulate $150,000 in 15 years. And that's it. So that concludes section 6. We've covered annuities, both ordinary annuity, annuity due, and then we've also solved for the interest rate and the number of compounding periods, or the number of payments as well.